if we could take at this point a bit of a tangent and talk about education and learning. If you're somebody listening to this who's a smart person, interested in programming, interested in AI, so I presume building something from scratch is a good beginning. So can you just take me through like what you would recommend people do?
So I would personally start, like you said, implementing a simple model from scratch that you can run on your computer. The goal is not, if you build a model from scratch, to have like something you use every day for your personal projects. Like it's not going to be your personal assistant replacing an existing open weight model or ChatGPT. It's to see what exactly goes into the LLM, what exactly comes out of the LLM, how the pre-training works in that sense, on your own computer preferably. And then you learn about the pre-training, the supervised fine-tuning, the attention mechanism. You get a solid understanding of how things work. But at some point, you will reach a limit because small models can only do so much. And the problem with learning about LLMs at scale is, I would say it's exponentially more complex to make a larger model because it's not that the model just becomes larger. You have to now think about sharding your parameters across multiple GPUs. Even for the KV cache, there are multiple ways you can implement it. One is just to understand how it works, just to grow the cache. It's like a cache you grow step by step by, let's say, concatenating lists, growing it. But then that wouldn't be optimal in GPUs. You wouldn't do that. You would pre-allocate a tensor and then fill it in. But that adds, again, another 20, 30 lines of code. And for each thing, you add so much code. And I think the trick with the book is basically to understand how the LLM works. It's not going to be your production level LLM. But once you have that, you can understand the production level LLM.
So you're trying to always build an LLM that's going to fit on one GPU.
Yes, most of them I have. I have some bonus materials on some MOE models. I think one or two of them, they may require multiple GPUs, but the goal is to have it on one GPU. And the beautiful thing is also you can self-verify. It's almost like RLVR when you code these from scratch. You can take an existing model from the Hugging Face transformer library. So the Hugging Face transformer library is great, but if you want to learn about LLMs, I think that's not the best place to start because the code is so complex because it has to fit so many use cases. Also, some people use it in production. It has to be really sophisticated and it's really intertwined and really hard. It's not linear to read.
It was started as a fine-tuning library, and then it grew to be like the standard representation of every model architecture and the way it's loaded. So Hugging Face is like the default place to get a model, and Transformers is the software that enables it so people can easily load a model and do something basic with it.
And all frontier labs that have open weight models have a Hugging Face Transformers version of it, like from DeepSeek to GPT OSS. That's like the canonical weight that you can load there. But again, also even Transformers, the library is not used in production. People use then SGLang or VLLM, and it adds another layer of complexity.
We should say that the Transformers library has like 400 models.
So it's a one library that tries to implement a lot of LLMs. And so you have a huge code base, basically. It's like huge. It's like, it's, I don't know, maybe millions, hundreds of thousands of lines of code. And it's like understanding the part that you want to understand is finding the needle in the haystack. But what's beautiful about it is you have a working implementation. And so you can work backwards from it. What I would recommend doing, or what I also do is, if I want to understand, for example, how Almost 3 is implemented, I would look at the weights in the model hub, the config file, and then you can see, oh, they used so many layers. They use, let's say, group query attention or multi-head attention in that case. And you see all the components in like a human readable, 100 lines of config file. And then you start, let's say, with your GPT-2 model and add these things, And the cool thing here is you can then load the pre-trained weights and see if they work in your model. And you want to match the same output that you get with a transformer model. And then you can use that basically as a verifiable reward to make your architecture correct. And then it's kind of, sometimes it takes me a day to, with Almost 3, the challenge was rope for the position embeddings. They had a yarn extension and there was some custom scaling there and I couldn't quite match these things. And in this struggle, you kind of understand things. But the cool thing is at the end, you have it correct because you can unit test it. You can check against the reference implementation. And I think that's maybe one of the best ways to learn, really, like to basically reverse engineer something. Yeah.
I think that is something that everybody that's interested in getting to AI today should do. And I think that's why I liked your book, is like I came to language models from this RL and robotics field. Like I never had taken the time to just like learn all the fundamentals. And this transformer architecture I describe as being like so fundamental as like deep learning was a thing that I had to learn in the past, and people need to do this. I think that where a lot of people kind of get overwhelmed is how do I apply this to have impact or find like a career path, because like AI and language models make this fundamental stuff so accessible and people with motivation will learn it. And then it's like, how do I get the cycles on goal to contribute to research? And I think that I'm actually fairly optimistic in this because the field moves so fast that a lot of times the best people like don't fully solve a problem because there's a bigger like a bigger problem to solve that's very low hanging fruit, so they move on. And I think that a lot of what I was trying to do in this RLHF book is like take post-training techniques and just describe how people think about them influencing the model and what people are doing. And then it's remarkable how many things I just think are just like people stop studying them or don't. So I think people trying to get narrow after doing the fundamentals is good. And then reading the relevant papers and being engaged in the ecosystem, it's like you actually, the proximity that random people have online from the leading researchers, like no one knows who all the anonymous account on X and ML is very popular for whatever reason. And no one knows who all these people are. Like it could just be random people that study the stuff deeply, especially with the AI tools, to just be like, I don't understand this, keep digging into it, I think is a very useful thing. But there's a lot of research areas that just like are maybe 3 papers that you need to read. And then one of the authors will probably email you back, but you have to put in a lot of effort into these emails to understand the field. Like I think it would be for a newcomer easily weeks of work to feel like they can truly grasp like what is a very narrow area. But I think going narrow after you have the fundamentals would be very useful to people, because it's like I became very interested in like character training, which is like how you make the model funny or sarcastic or serious, and like what do you do to the data to do this. And it's like a student at Oxford reached out to me. It's like, hey, I'm interested in this. And I advised him. And it's like, that paper now exists. And it's like, I don't know, there's like 2 or 3 people in the world that were very interested in this. He's a PhD student, which gives you an advantage. But like, for me, that was a topic I was waiting for someone to be like, hey, I have time to spend cycles on this. And I'm sure there's a lot more very narrow things where you're just like, oh, it doesn't make sense that there was no answer to this. And I think that it's just like, there's so much information coming that people are like, I can't grab onto any of these. But if you just actually stick in an area, I think there's a lot of interesting things to learn.
Yeah, I think you can't try to do it all because it would be very overwhelming and you would burn out if you try to keep up with everything. For me, for example, I haven't kept up with computer vision in a long time, just focused on LLMs. But coming back to your book, for example, I think this is also a really great book and a really good bang for the buck because you want to learn about RLHF. I wouldn't go out there and read RLHF papers because you would be spending 2 years.
Contradict. I just edited the book and I was like, there's a chapter where I had to be like, X papers say one thing and X papers say another thing, and we'll see what comes out to be true.
What are some of the, just to go through some of the table of contents, some of the ideas we might have missed in the bigger picture of the post-training? So first of all, you do the problem setup, training overview, what are preferences data in the optimization tools, reward modeling, regularization, instruction tuning, rejection sampling, reinforcement learning, i.e. policy gradients, direct alignment algorithms, then constitutional AI and AI feedback, reasoning and inference time scaling, tool use and function calling, synthetic data and distillation, evaluation, and then open question section, over optimization, style and information, and then product, UX, character, and post-training. So what are some ideas worth mentioning that connect both the educational component and the research component? You mentioned the character training, which is pretty interesting.
Character training is interesting because there's so little out of it, but we talk about how people engage with these models and like we feel good using them because they're positive, but that can go too far. It could be too positive. And it's like, essentially it's how do you change your data and or decision making to make it exactly what you want. And OpenAI has this thing called a model spec, which is essentially their internal guideline for what they want the model to do. And they publish this to developers. So essentially you can know what is a failure of OpenAI's training, which is like they have the intentions and they haven't met it yet, versus what is something that they like actually wanted to do and that you don't like. And that transparency is very nice, but all the methods for curating these documents and how easy it is to follow them is not very well known. I think the way the book is designed is that the reinforcement learning chapter is obviously what people want because everybody hears about it with RLVR. And it's the same algorithms and the same math, but it's just like you can use it in very different documents. So I think the core of RLHF is like how messy preferences are, is essentially rehash of a paper that I wrote years ago. But this is essentially the chapter that'll tell you why RLHF is never ever fully solvable, because like the way that even RL is set up is that it assumes that preferences can be quantified and that multiple preferences can be reduced to single values. And I think it relates in the economics literature to the von Neumann-Morgenstern utility theorem. And like that is the chapter where all of that philosophical, economic, and like psychological context, it tells you what gets compressed into doing RLHF. So it's like you have all of this, and then later in the book, it's like you use this RL math to make the number go up. And I think that's why I think it would be very rewarding for people to do research on, is because it's like quantifying preferences is something that is just like humans have designed the problem in order to make preferences studyable. But there's kind of fundamental debates on like, an example is in a language model response, you have different things you care about, whether it's accuracy or in style. And when you're collecting the data, they all get compressed into like, I like this more than another. And it's like that is happening. And there's a lot of there's a lot of research in other areas of the world that go into like, how should you actually do this? I think social choice theory is the subfield of economics around how you should aggregate preferences. And there's like, I went to a workshop that published a white paper on like, how can you think about using social choice theory for RLHF? So I mostly would want people that get excited about the math to come and have things where they can stumble into and learn this kind of broader context. I think there's a fun thing. I just keep a list of all the tech reports that I like of reasoning models. So in chapter 14, which is kind of like a short summary of RLVR, there's just like a gigantic table where I just like list every single reasoning model that I like. So there's just like, I think in education, a lot of it needs to be like, at this point, it's like what I like, because the language models are so good at the math, where it's like famous paper, direct preference optimization, which is like a much simpler way of solving the problem than RL. The derivations in the appendix skip steps of math. And it's like, I tried for this book, like I redid the derivations and I'm like, what the heck is this log trick that they use to change the math? But doing it with language models, they're like, this is the log trick. And I'm like, I don't know if I like this, that the math is so commoditized. I think like some of the struggle in reading this appendix and following the math, I think is good for learning. And
yeah, so we're actually returning to this often just on the topic of education. You both have brought up the word struggle quite a bit. So there is value. If you're not struggling as part of this process, you're not fully following the proper process for learning, I suppose.
Some of the providers are starting to work on models for education, which are designed to not give, actually, I haven't used them, but I would guess they're designed to not give all the information at once and make people work to do this. So I think you could train models to do this, and it would be a wonderful contribution where like all of this stuff in the book, you have to reevaluate every decision for it, which is such a great example. I think there's a chance we work on it at AI too, which I was like, oh, I think this would be so
Makes
fun.
sense. I do something like that. Did that the other day for video games, for example. I sometimes for my pastime play video games. Like I like video games with puzzles, so like Zelda and Metroid. And there's this new game where I got stuck, and I really got stuck and was okay. I don't want to struggle for, like 2 days. And so I used an LLM, but then you say, hey, please don't add any spoilers. Just, I'm here and there. What do I have to do next? And the same thing you can do, I guess, for math, where you say, okay, I'm here at this point. I'm getting stuck. Don't give me the full solution, but what is something I could try, like where you kind of carefully probe it. But the problem here is I think it requires discipline, and a lot of people do math for there are a lot of people who enjoy math, but there are also a lot of people who need to do it for their homework, and then it's like the shortcut. And yeah, we can develop an educational LLM, but the other LLM is still there, and there's still a temptation to use the other LLMs.
I think a lot of people, especially in college, they understand the stuff they're passionate about, they're self-aware about it, and they understand it shouldn't be easy. Like I think we just have to develop a good taste. We talk about research taste, like school taste, about stuff that you should be struggling on and stuff you shouldn't be struggling on, which is tricky to know because sometimes you don't have good long-term vision about what will be actually useful to you in your career. But you have to develop that taste. Yeah.
I was talking to maybe my fiance or friends about this, and it's like there's this brief 10-year window where all of the homework and all the exams could be digital. But before that, everybody had to do all the exams in Blue Book because there was no other way. And now after AI, everybody's going to need to be in Blue Books and oral exams because everybody could cheat so easily. It's like this brief generation that had a different education system that like everything could be digital, but you still couldn't cheat. And now it's just going to go back. It's just pretty funny.
You mentioned character training. Just zooming out on a more general topic. For that topic, how much compute was required? And in general, to contribute as a researcher, are there places where not too much compute is required, where you can actually contribute as an individual researcher?
On the character training thing, I think this research is built on fine-tuning about 7 billion parameter models with LoRa, which is like essentially you only fine-tune a small subset of the weights of the model. I don't know exactly how many GPU hours that would take,
but it's doable.
Not doable for every academic. So the situation for some academics is like so dire that the only work you can do is doing inference, where you have closed models or open models and you get completions from them and you can look at them and understand the models. And that's very well suited to evaluation, which you want to be the best at creating representative problems that the models fail on or show certain abilities, which I think that you can break through with this. So I think that the top end goal for a researcher working on evaluation, if you want to have career momentum, is the frontier labs pick up your evaluation. So it's like, you don't need to have every project do this. But if you go from a small university with no compute and you figure out something that Claude struggles with, and then the next Claude model has it in the blog post, like there's your career rocket ship. I think that's hard, but it's like, if you want to scope the maximum possible impact with minimum compute, it's something like that, which is just get very narrow. And it takes learning of where the models are going. So you need to like build a tool that tests where not Claude 4.5 will fail. If you're going to do if I'm going to start a research project, I need to think where the models in 8 months are going to be struggling.
But what about developing totally novel ideas?
This is a trade-off. I think that if you're doing a PhD, you could also be like, it's too risky to work in language models. I'm going way longer term, which is like, what is the thing that's going to define language model development in 10 years? Which I think that I end up being a person that's pretty practical. I mean, I went to my PhD where it's like, I got into Berkeley, worst case, I get a master's and then I go work in tech. It's just like, I'm very practical about it. So I'm like, the life afforded to people to work at these AI companies, the amount of like OpenAI's average compensation is over $1 million in stock a year for an employee. Any normal person in the US to get into this AI lab is transformative for your life. So I'm pretty practical of like, there's still a lot of upward mobility working in language models if you're focused. And the outcomes is like, look at these jobs. But from a research perspective, the transformative impact in these academic awards, it's like be the next Jan LeCun, is from not caring about language model development very much.
So it's a big financial sacrifice in that case.
So I get to work with some awesome students and they're like, should I go work at an AI lab? And I'm like, you're getting a PhD at a top school or you're going to leave to go to a lab? I'm like, I don't know. Like, if you go work at a top lab, I don't blame you. Don't go work at some random startup that might go to zero. But if you're going to OpenAI, I'm like, it could be worth leaving a PhD for.
Let's more rigorously think through this. So where would you give a recommendation for people to do a research contribution? So the options are academia, so get a PhD, spend 5 years publishing. Compute resources are constrained. There's research labs that are more focused on open weight models, and so working there, or closed frontier labs, research labs. OpenAI, Anthropic, XAI, so
on. The two gradients are the more closed, the more money you tend to get, but also you get less credit. So in terms of building a portfolio of things that you've done, like it's very clear of what you have done as an academic and you have done this. And versus if you are going to go trade this fairly reasonable progression for being a cog in the machine, which could also be very fun. So I think it's very different career paths, but the opportunity cost for being a researcher is very high because PhD students are paid essentially nothing. So I think it ends up rewarding people that have a fairly stable safety net and they realize that they can operate in the long term, which is they want to do very interesting work and get a very interesting job. So it is a fairly Like, it was a privileged position to be like, I'm going to see out my PhD and figure it out after because I want to do this. And I think a lot of at the same time, the academic ecosystem is getting bombarded by funding getting cut and stuff. So there's just like so many different trade-offs where I understand plenty of people that are like, oh, I can't deal with this funding search. My grant got cut for no reason by the government, or I don't know what's going to happen. So I think there's a lot of uncertainty and trade-offs that, in my opinion, favor just like take the well-paying job with meaningful impact. Because like not also like you're getting paid to sit around at OpenAI. You're building like the cutting edge of things that are changing millions of people's relationship to tech.
But publication-wise, they're being more secretive, increasingly so. So you're publishing less and less and less and less, and so you are having a positive impact at scale, but you're a cog in the machine.
I think honestly, it hasn't changed that much. So I've been in academia. I'm not in academia anymore. At the same time, I wouldn't want to miss my time in academia. But what I wanted to say before I get to that part, I think it hasn't changed that much. I was working in I was using AI or machine learning methods for applications in computational biology with collaborators, and a lot of people went from academia directly to Google. And I think it's the same thing. Back then, the professors were like, sad that their students went into industry because they couldn't carry on their legacy in that sense. And I think it's the same thing. I mean, it's like it hasn't changed, I think, that much. The only thing that has changed is the scale. But, cool stuff was always developed in industry that was closed. You couldn't talk about it. And I think the difference now is, your preference. Do you like to talk about your work, publish, or, you are more in a closed lab? That's one difference, the compensation, of course, but it's always been like that, I think. So it really depends on, where you feel comfortable. And it's also nothing is forever. The only thing right now is there's a third option, which is starting a startup. That's a lot of people doing startups. Very risky move, but can be is a high risk, high reward type of situation where joining an industry lab, I think, is pretty safe. Also upward mobility. Honestly, I think if once you have been at a industry lab, it will be easier to find future jobs. But then again, it's like, how much do you enjoy the team and working on proprietary things versus how do you like the publishing work? I mean, publishing is stressful. It is, acceptance rate at conferences can be arbitrary, can be very frustrating, but also high reward. If you have a paper published, you feel good because your name is on there, you have a high accomplishment, and
I feel like my friends who are professors seem on average happier than my friends who work at a frontier lab, to be totally honest, because that's just grounding, and the frontier labs definitely do this 996, which essentially is shorthand for work all the time.
Yep.
Can you describe 996 as culture that's, I believe you could say, invented in China and adopted in Silicon Valley? What's 996? It's 9 a.m. to 9 p.m. and
6 days a week.
6 days a week. What is that? 72 hours? Okay. So what is this basically the standard in AI companies in Silicon Valley? More and more this kind of grind mindset?
Yeah, I mean, maybe not exactly like that, but I think there is a trend towards it. And it's interesting. I think it almost flipped because when I was in academia, I felt like that because as a professor, you had to write grants, you had to you had to teach, and you had to do your research. It's like 3 jobs in one, and it is more than a full-time job if you want to be successful. And I feel like now, like Nathan just said, the professors, in comparison to a lab, I think they have less, like, even maybe pressure or workload than at a frontier lab because
they work a lot. They're just so
Yeah.
fulfilled by
Yeah.
like working with
Okay.
students and having a constant runway of mentorship and like a mission that is very people oriented. I think in an era when things are moving very fast and are very chaotic is very rewarding to people.
Yeah, and I think at a startup, I think it's this pressure. It's like you have to make it, and it's like it is really important that people put in the time. But well, it is really hard because you have to deliver constantly. And I've been at a startup. I had a good time, but I don't know if I could do it forever. It's like a interesting pace, and it's exactly like we talked about in the beginning. These models are leapfrogging each other, and they are just constantly like trying to take the next step compared to the competitors. It's just ruthless, I think, right now.
I think this leapfrogging nature and having multiple players is actually an underrated driver of language modeling process, where competition is so deeply ingrained to people, and these companies have intentionally created very strong culture. Like Anthropic is known to be so culturally like deeply committed and organized. I mean, like we hear so little from them, and everybody at Anthropic seems very aligned. And it's like being in a culture that is super tight and having this competitive dynamic is like talk about a thing that's going to make you work hard and create things that are better. So I think that but that comes at the cost of human capital, which is like you can only do this for so long, and people are definitely burning out. I think I wrote a post on burnout as I've tried in and out of this myself, especially trying to like be a manager of full mode training. It's a crazy job doing this. The book Apple in China by Patrick McGee, he talked about how hard the Apple engineers worked to set up the supply chains in China. And he was like, they had saving marriage programs. And he told in a podcast, he was like, people died from this level of working hard. So I think that's just like, it's a perfect environment for creating progress based on human expense. And there's going to be a lot of the human expense is the 996 that we started this with, which is like people do really grind.
I also read this book. I think they had a code word for if someone had to go home to spend time with their family to save the marriage. And it's crazy. Then the colleagues honestly, okay, this is like red alert for this situation. We have to let that person go home this weekend. And but at the same time, I don't think they were forced to work. It's really, they were so passionate about the product, I guess, that it is you get into that mindset. And I had that sometimes as an academic, but also as an independent person, I have that sometimes. I overwork, and it's unhealthy. I had back issues, I had neck issues because I did not take the breaks that I maybe should have taken. But it's not because no one forced me to. It's because I wanted to work, because it's
that's what
exciting stuff.
OpenAI and Anthropic are like. They want to do this work.
Yeah, but there's also a feeling, a fervor that's building, especially in Silicon Valley, aligned with the scaling laws idea, where there's this hype where the world will be transformed on a scale of weeks, and you want to be at the center of it. And then I have this great fortune of having conversations with a wide variety of human beings. And from there, I get to see all these bubbles and echo chambers across the world. And it's fascinating to see how we humans form them. And I think it's fair to say that Silicon Valley is a kind of echo chamber, a kind of silo and bubble. I think bubbles are actually really useful and effective. It's not necessarily a negative thing, because it could be ultra productive. It could be the Steve Jobs reality distortion field, because you just convince each other the breakthroughs are imminent, and by convincing each other of that, you make the breakthroughs imminent.
Bern Hobart wrote a book classifying bubbles, but essentially one of them is financial bubbles, which is like speculation, which is bad. And the other one is like, I don't know the term, but effectively for build outs, because it pushes people to build these things. And I do think AI is in this, but I worry about it transitioning to a financial bubble, which is like,
but also in the space of ideas, that bubble, you are doing a reality distortion field, and that means you are deviating from reality. And if you go too far from reality, while also working, 996, and you might miss some fundamental aspects of the human experience, including in Silicon Valley. And this is a common problem in Silicon Valley. It's a very specific geographic area. You might not understand the Midwest perspective, the full experience of all the other different humans in the United States and across the world, and you speak a certain way to each other. You convince each other of a certain thing. And that can get you into real trouble, whether AI is a big success and becomes a powerful technology, or it's not. In either trajectory, you can get yourself into trouble. So you have to consider all of that. Here you are, a young person trying to decide what you want to do with your life.
The thing that is, I don't even really understand this, but the SF AI memes have gotten to the point where permanent underclass was one of them, which was the idea that the last 6 months of 2025 was the only time to build durable value in an AI startup or model. Otherwise, all the value will be captured by existing companies, and you will therefore be poor, which, like, that's an example of the SF thing that goes so far. I still think for young people that going to be able to tap into it, if you are really passionate about wanting to have an impact in AI, like being physically in SF is the most likely place where you're going to do this, but it has trade-offs.
I think SF is an incredible place, but there is a bit of a bubble. And if you go into that bubble, which is extremely valuable, just get out also. Read history books, read literature, visit other places in the world. Twitter is not, and Substack is not the entire world.
I think I would say one of the people I worked with is moving to SF, and it's like I need to get him a copy of The Season of the Witch, which is a history of SF from like 1960 to 1985, which goes through like the hippie revolution, like all the gays kind of taking over the city and that culture emerging, and then the HIV/AIDS crisis and other things. And it's just like that is so recent and so much turmoil and hurt, but also like love in SF. And it's like no one knows about this. It's a great book, Season of the Witch. I recommend it. A bunch of my SF friends who do get out recommended it to me, and I think that it's just like living there. Like I lived there and I didn't appreciate this context, and it's just like so recent.